The observer effect. Say you wanted to take pictures with your camera after observing a particular scene. For example, you want to capture a scene of two lovers kissing, but when you look at the photo, the scene changes into two people fighting each other. This is similar to how the observer effect works. In the quantum world, observing particles can influence their actions. On the other hand, in the everyday world, observing things for what they are doesn't change their nature or what they're doing. But in quantum physics, particles are shy enough to change their behavior when they know you're observing them. It's like someone is invisible only whenever another person is looking at them. Observation is commonly supposed to be a neutral act that doesn't change the outcome of an experiment or any observable phenomena. A house will always be burning if you observe the flames turning wood into ash. In the quantum world, however, observing particles' actions can change how they act. And there's a reason why this makes sense. Picture this. You aren't observing anything in a pitch-black room that's too dark for anyone to see. But when you turn your flashlight on, the room changes from dark to semi-lit simply because you used a tool to try to observe your surroundings. You can also picture it as putting a thermometer in hot water. Because the thermometer is colder than the water in the pot, adding it to measure the water's temperature will slightly alter the water's temperature compared to what it was before. That is basically how the observer effect works. Observation can change the behavior of atoms because measuring tools can already have a huge effect on the small events happening in the quantum world, where even a speck of dust is already an entire planet larger than an atom.